Hello everyone, my name is Lingxiao. My supervisor is Professor Pei Yan. I'm studying in the Department of Computer and Information Systems, Graduate School of Computer Science and Engineering, University of Aizu. My topic is kernelized linear principal component discriminant analysis. I will introduce 6 parts. The first 3 parts is about the background knowledge, and the fourth and the fifth part is my research work. The last part is about conclusion. Firstly, I will introduce 2 data analysis methods. The first one is principal component analysis, PCA. Its objective is to find a set of vectors in the space containing the maximum amount of variance in the data. It can be presented by this equation. As shown in this picture, PC1 is our target direction because all the projections of all of the data onto this direction are the most decentralized. That is, projections has the maximum amount of variance, and this part is the amount of variance. The second data analysis method is linear discriminant analysis, LDA. It has 2 objectives: to minimize distance of data within one group as smaller as possible. It can be presented by this part. And to maximize distance between groups as bigger as possible. The first objective is to minimize distance of data within one group as smaller as possible. It can be shown as this part. This is the distance within one group. And to maximize distance between groups as bigger as possible, it can be presented by this part. It is about the distance between groups. As shown in this picture, LDA1 is our target direction because in the blue class, the projections of all blue dots onto this direction is the most centralized, and also in the red class, it satisfies the first objective, and the mean of projections of all the blue dots onto this direction is located like here, and the mean of all the projections of red dots onto this direction is located here. This distance is the largest one among that of all the other directions. It satisfies the second objective, so that LDA1 is our target direction. This part is also the background knowledge. It is a paper from Professor Pei that called Linear Principal Component Discriminant Analysis, LPCDA. It introduced a uniform framework of 7 methods spied by the linear combinations of 3 objectives of PCA and LDA. As shown in the PCA, it has this objective of maximum variance of all the data. As shown in the LDA, it has 2 objectives: the minimal distance within group and the maximal distance between groups. As shown here, the author received 7 methods through the linear combination of these three objectives, as shown in this table, where the method number 3 is LDA and the method number 4 is PCA. And the other 5, method number 1, 2, 5, 6, 7 is new data analysis method. This part is a kernel method. It is to map the data into higher dimensional space to increase their dimension in order to express the data with a linear model instead of non-linear model in original space. I explain it in this picture. In this space of 2 dimensions, if we want to separate the dots and the stars, we have to use a circle. While if put this data into this space of dimension 3, we only need a plane to separate the dots and the stars. That is, we change a non-linear model into a linear model with more easier calculation. This is the kernel method's theory. As for the kernel method, we also need to learn about the kernel function and the kernel matrix. It is known in the in high dimensional space. This part is my research work. I realized 7 methods of LPCDA in the feature space by using kernel method, which is referred to kernelized LPCDA. In detail, that is, I mapped the original data X into feature space, referred as X, and we need to solve these objectives in the feature space by deal with the matrix C as B as W and receive the target direction V, while the feature map X is implicit, so the matrices C as B as W are unknown in the feature space, so that we cannot derive the desired V, but we can use kernel matrix K to present the target function through the matrix calculation and derive the V, because kernel matrix is known in the feature space. From the calculation, we can present the objectives of each method as these equations. These matrices W, B, K are all known in the feature space, so that these equations are all solvable, and our target V can be represented by this equation. As new data coming is projections onto V can be calculated like this equation, and this part is known in the feature space, so that we finish the theoretical implementation of kernelized LPCDA. And we do experiments to evaluate our proposed method. We use 2 datasets, feature iris and 1 and 2 kernel functions, polynomial kernel and Gaussian kernel. In polynomial kernel function, there is a parameter gamma, and the Gaussian kernel has a parameter sigma. Figure 1 shows the experiment results on fish iris dataset by using Gaussian kernel with the parameter sigma equals to 0.2. we can observe the original data. Firstly, it has 3 classes, and the following is the classification results of each method. It shows that our proposed method number 1, number 5, number 6, number 7 has excellent results as JDA and better results than KPCA. And our proposed method number 2 has similar results as KPCA. So that it indicates that our proposed method perform better than KPCA, and our proposed method number 2 performs no worse than KPCA. It shows our advantages. It shows our proposed method's advantages. We also evaluate our methods quantitatively. As introduced above, there are 3 objectives: the maximal total variance, minimal distance within class, and maximal distance between classes. So that we calculate 5 items, that is total variance of each class, and the distance between classes. As shown in this table, our proposed method number 7 performs best in the item of total variance of each class, and the method number 4, that is KPCA, performs best in the item of total variance, and our proposed method number 6 performs best in the item of distance between 2 classes. So that we can it indicates that some of our proposed method performs better than KPCA and LDA in some of items quantitatively. Figure 2 shows the results on fish iris dataset by using polynomial kernel with the parameter gamma equals to 3. Generally speaking, the results is no better than Gaussian kernel, and our proposed method number 1, number 2, number 5 has the similar results as JDA and KPCA, and our proposed method number 6 performs not bad. It indicates that our proposed method performs no worse than JDA and KPCA. And the quantitative results shows that our proposed method number 6 performs best in the item of total variance and distance between 2 classes, and number 7 performs best in the item of total variance of each class, so that obviously it shows that our proposed method performs better than KPCA and JDA in all of the items quantitatively. Figure 3 shows the results on one dataset by using Gaussian kernel with the same parameter value. We can observe the original data. Firstly, there are also 3 classes, and our proposed method number 1, number 2, number 5, 6, 7 have the excellent results as JDA, as much better results than KPCA. It obviously shows that our proposed method performs much better than KPCA and no worse than JDA, which is our advantages. And the quantitative results show that JDA performs best in the item of total variance and the distance between two classes. And our proposed method number 2, number 1, number 5 performs best in the item of total variance of class 1, 2, 3 respectively. So that we can still conclude that some of our proposed method plays better than PCA and LDA, than KPCA and JDA in some of items quantitatively. Figure 4 is the results on one dataset by using polynomial kernel with the same parameter value. Also, generally speaking, it plays the results is perform. All of the results perform no better than Gaussian kernel. And our proposed method number 1, number 2 get the similar results as JDA and KPCA. So that it shows that our proposed some of our proposed methods plays no worse than KPCA and JDA visually, and the quantitative results is much better. Our proposed method number 6 performs best in total variance and distance between two classes, and number 7 performs best in item of total variance of each class. So that it indicates our proposed method performs better than KPCA and JDA in all of our items, which shows our advantages. Now we come to the conclusion part. I introduced the kernelized linear principal component discriminant analysis from the theoretical implementation and the evaluation results. In the evaluation part, we use 2 datasets, Fisher iris and 1, and we choose 2 kernel function, Gaussian and polynomial kernel, and we receive the results. That is, some of our proposed methods perform better than KPCA or JDA, and performs no worse than KPCA or JDA quantitatively and visually. So that our proposed method has advantages. There are also some problems to be solved. The most important one is the optimization. We use 2 datasets and 2 kernel functions in our evaluation part, so that which kernel function to select and how to select kernel function parameter values can lead to optimal results. It's what we need to think about in the future. And in LPCDA, the author received 7 methods by the linear combination of 3 objectives, and we can explore if there are some other combination of objectives to receive some other new data analysis methods. and we can think about some more practical applications to receive more realistic or efficient results, and significance of kernelized LPCDA can be think about in the future. I finished my presentation. Thank you.